All right. I'm so excited to be here with Peter, the VP of Product and Partnerships at OpenAI, a day after the GPT-4 launch, one of the most exciting launches I think ever in Silicon Valley. So congratulations, Peter.
Thank you
Thanks
so
for joining.
much, and thanks for having me. Super excited to chat.
All right, so I know you're busy and we have limited time, and we crowdsourced way too many questions, so I'm just going to rapid fire them at you if that's all right.
Yeah, let's do it.
So let's do it. So first question is, what are some specific applications of GPT-4 that you and your team are most enthusiastic about?
I mean, there are tons of them, but like just to call out a few, like one thing that I really thought was super cool was Be My Eyes, who is using kind of the visual inputs to GPT-4 to help visually impaired people. I mean, it's like, computer vision used to be this thing where you did object recognition and so on, and suddenly you can do much more. You can like ask like, hey, is something wrong in my outfit? Something I should fix? Or, I have these ingredients. What should I cook? Like it's opens up a whole new kind of just range of applications.
And you're originally a vision guy, right? So that must be wild to see this approach work so well.
That's right. It's sort of crazy. Like, yeah, all we needed was language models.
Awesome. Okay. Does a lot of prompt engineering become redundant given the larger context length and the ability to supply more in-context examples in the prompt?
Oh yeah, this is super interesting. I sort of feel like I I keep on thinking that something is both right and wrong with prompt engineering. Like, ultimately, prompt engineering, when we should think about it, we should think about it like, how good are you at this specifying task? Like, a good manager should be able to tell, their employee, whatever, this is your job, this is what you should work on. There shouldn't be super much ambiguity, and that's kind of what prompt engineering is about. But like this ability to just have a conversation with the model and like fix it, like no, that was too formal, or no, like make it a little upbeat, add a joke here, like that sort of interaction. That's how I think we would kind of think about language models, much more than like adding lots of examples or like writing very specified instructions. Like, let's just have a conversation with the model and it would kind of pick up on what I want over time.
Totally makes sense. All right, now here's a question we got the most in different forms, but why weren't you able to keep the training data on the training of GPT-4 on more up-to-date data?
Oh yeah, so that's such an interesting question. Like, so ultimately, training these models just take a long time. So that's ultimately the answer. Here is this that
Really?
I can't tell you exactly how long it took to train this, but like there's processes here of like at some point you're doing testing on certain kinds of data, and then you want to lock down that data. And not change it too much, so you can really trust that when you run the big kind of training run, nothing's going to go wrong. That just means that you're going to have stale data at some point. Obviously, like getting fresh data into the models is a pretty big question that we get over and over again. So it's something that's definitely on top of our mind to kind of fix going forward. But ultimately, that is, it just takes time to train these models.
Okay. All right. Considering that GPT-4 is multimodal now, do you imagine future foundation models to be multimodal by design? And I guess, do you have any comments on what the biggest blockers were when introducing the multimodal component?
Yeah, that's a good question. I definitely think that like multimodal is sort of the future. Like this is you just give the models abilities to understand many more concepts. They kind of understand things like physics concepts based on looking at images, or they can understand if, like, you can imagine eventually these models kind of dealing with more modalities like audio and so on. Like, it's pretty clear that the future here is just more and more kind of multimodal models. And some components are already there today, like with Whisper. You can take you can take audio and turn it into text and so on. So it's like all of these things eventually will get connected. And I think in terms of challenges, I would confess here that I wasn't on the research team that did a lot of the amazing work to get GPT working, but I just know that going scaling, going from like small models to like these enormous models that GPT-4 is that's like a huge challenge in itself. You kind of need to do a lot of science to understand, like on smaller models, to see like here's how good it is and here's how good it's going to be when we scale it up. And that it just requires a lot of like very detailed kind of investigations and so on, and a lot of kind of like just hard work, which that team did.
Totally. Were there any new like specific challenges with GPT-4 different than previous models, or is it just sort of like trying to get even another level of scale?
You know, I ultimately it is, just another level of scale. But I would say that we work in like all aspects of that, whether it's data, whether it's how to most efficiently use the compute, architectures of models, and so on. All of these things are things that we kind of tune and tweak continuously. But ultimately, a big part of it is really being able to scale. And as you scale, every order of magnitude, there's just more and more things that break, even in your infrastructure, And so, we have just an incredibly talented infrastructure engineering team that is like made up of both engineers and researchers that have built this incredible system for being able to train these models. And there's just so many little things that you need to get right, because if you have a bug somewhere, it's going to propagate immediately. And so, like, I think one of the biggest like mantras essentially that team has is like, don't have bugs, which is like seems like the most hardest thing to do as a software engineer.
Good advice though. Don't have bugs.
Yeah.
So here's another question. I don't even know if it's fully formed, but do you have a sense or a guess of like the order of magnitude of experiments running in a typical day, like in the weights and biases notion of experiments, like training something? Is it like a handful or millions, or what do you think it is?
It's a good question. I would say like there's probably on the order of like I don't know, like somewhere between 100 and 200 people essentially doing some sort of research at OpenAI, and each of them are probably running on the order of like a few experiments per week. So that probably makes it like multiple hundreds of experiments per week. Like some of them will take like some experiments take weeks, some experiment takes like hours, right? But It's sort of like that's probably the order of magnitude.
Got it. Okay. To the extent that you can comment, what was the most useful type or source of data for training GPT-4?
Oh, I feel like it's just like the text on the internet is probably the answer here. These models are just incredibly data hungry. So just finding more and more and more of this, like we have a whole team that's just like basically focused on like how can we bring more data into these models. So I think at this point it's like almost to some extent it's like less about the particular data and more about more data. So that's probably how I would think about it.
Is there any particular task? I mean, I saw all these tasks that you showed GPT-4 getting better at. Is there any task where like it's been surprisingly hard given how impressive like all these like every version of LLMs is? Anything stand out as like you would have thought it would have gotten solved by an earlier version?
Oh, that's a good question. I mean, it is still surprising to me. I feel like at this point, like GPT-4 is quite good at just doing mental or arithmetic and stuff like that. But like, it took all the way to GPT-4 to kind of get it to be fairly robust at that. It would just make these silly mistakes for even up to 3.5, and it's still, just to be clear, it still makes some silly mistakes. But, it's like, the way I look at it, it's kind of weird, almost like a weird savant in some sense, right? Like it has these amazing capabilities on some dimensions and then makes these like incredibly stupid mistakes that a human just wouldn't make unless the human is drunk or something, right? Like, but that's sort of like that's what it feels like sometimes with the model. It's like you kind of never know. Did you get the kind of early morning version or like the late at night after multiple drinks version? And like the weirdest thing about this is that sometimes like even like prompting the model, it seems to matter. Like if you tell the model, hey, you're a genius at math, it would do better at math than if you tell it like you're not very good at math, right? Like it's,
really? So you can't like prod it, like you can't get it riled up and then make it.
Yeah. Exactly. And so the models are like, it's still very vulnerable to this kind of stuff. So, but I think that's like, that's one thing. I think it is, I mean, it's like, it's also funny. You might have seen in the in Greg Brockman's demo that he did, like the whole thing about like summarizing with a single letter, the same letter starting every word. I mean, it's kind of it's sort of weird how it just happens that once you reach a certain scale, it kind of just gets it. And I think there's a number of those where it's just like, it's kind of weird how you just, I think it's kind of called grokking, this phenomenon where you train it, it doesn't do very well, and then suddenly it just gets it. Something kind of, it forms some sort of representation and just kind of gets it. And so there's been a few of those, and it's like, I think it's always surprising when they happen, and you're like, why didn't it happen earlier? And I don't know.
Interesting. Cool. Okay, here's an interesting question, maybe useful for us at Wits and Biases. What kind of visualization tools would be most helpful as we continue to build on these models? Or do you have any ideas of what might be helpful for people building on top of these models?
Oh yeah, that's such a great question, because I think this is like kind of evolving more and more as these models get better and better. It used to be the case where I think kind of all you cared about was really like perplexity and so on as you were training it. It's like that was mostly what you were optimizing. But I think we're getting to a point now like where you kind of you really want to visualize how like dig into kind of the mistakes that the models are doing and so on. Like we move to a world where I think you can get really far with like prompting and whether it's like through conversations or a single kind of prompt. But then you will get to some point where you can kind of you can fine tune these models with even more data. And at that point, I think the paradigm now is that you don't need a ton of data, but you need to make sure that data is kind of really, really high quality. So understanding kind of a way to see like where are mistakes made, how do you automatically kind of build, we ship this open source library called OpenAI evals that kind of makes it easy for you to build automated evals. So I think like that would be a big part of the workflow, and allowing people to see overall trends, but dig into the examples. Because oftentimes what we find that at the end of the day, like examples are underspecified and so on. And so you just need to be so way more careful now that like the models are so good that like you're not seeing weird stuff because the model is bad versus like you just had a mistake in your data set.
Makes sense. Okay. So I guess here's the summary of this question is, how many people worked on GPT-4? Like how many ML engineers did it take to train this thing?
Oh, that's a good question. I mean, it's just like, I feel like all of OpenAI worked on this one in one way or another, because like we have this whole kind of process, like a big, like, all the data set work that goes into it, all of the infrastructure engineering that built the data centers, that kind of built the infrastructure on top of those data centers to train these models, then all the kind of science and stuff that went into actually the pre-training, and then we do this kind of fine-tuning on top with RL from human feedback. So I feel like at the end of the day, it's got to be like probably out of the 300 plus people at OpenAI, probably at least 2/3 of the company worked on some aspect of this.
Okay, and final question. Since this is our user conference and you are such a high-profile user or OpenAI, I'm curious if you could say a little bit about how OpenAI uses weights and biases, and if you have a favorite feature or part of weights and biases. We'd love to know about that.
Yeah, I mean, we use it for pretty much all of our model training. So just like just tracking them. I think there's a lot of kind of just sharing of like the fact that you can easily share kind of training runs and stuff like that. It's a super used feature. But I think one thing that these days I do way less of that sort of work. So one of the features I really like is kind of the ability to kind of have reports and so on, where people. So we use that quite heavily. It depends a little bit on the team, but a number of teams are using that quite heavily to kind of really have clear hypothesis. Here's like the hypothesis. Here are the experiments that were run to kind of validate or invalidate that hypothesis. Here's the conclusion. You have all these like mini scientific papers essentially on all of the stuff that's happening at OpenAI, which is like incredibly interesting to kind of follow along with.
Fantastic. That sounds very interesting. Thank you so much, Peter. It's really nice to have your time, especially so close to after your big launch. And congratulations. We're loving using it internally here.
Thank you so much for having me. This was super fun, and can't wait to see what you all build with GPT-4.
Awesome. Take care.